So this is a hot water pressure washer that I picked up a couple months ago for pretty cheap, and as you can see, it definitely needs a little bit of work to it. The electrical is kind of sketchy. It all works, but it definitely needs to be fixed. So I'm going to be rewiring everything, redoing all the plumbing on it, replacing all these lines that are, not in very good shape, all the fuel lines underneath. When I first got it and got it working, I found a hole in the coil. So I did take it all apart and I welded up the coil and got that all fixed. Now it holds pressure good. I'll put up a picture that I have of what that looked like. But it's an Alkota 2120E. I'm not really sure what all the spec stands for, but Alkota is still in business making pressure washers, and it's from the 90s. I do have the manual for it, which is kind of handy because it'll help me get through all the electrical that's a real big mess, but hopefully we can get it somewhat restored and a little bit safer and in better working condition. So this is the burner setup, pretty much the same burner that you'd find on your furnace for your house. This one runs off of kerosene. I suppose if it had the right nozzle, it would be able to run off of diesel or home heating fuel. But we're going to start with the electrical side of things and get it all taken apart. So pretty much you have your 110 input going into your box here. You got a switch for your pump and a switch for your burner. You got two leads going out. One of them goes up to your motor, and the other one goes up to this vacuum switch. So the way the vacuum switch is that it will only trigger the burner to be on if there's vacuum. So there's only vacuum when you're actively using the pressure washer and there's flow through it. So if your hand's off the trigger, no flow, the burner shuts off, pull the trigger, now you have flow. This drops down, completes the circuit, turns your burner on, and that way you have hot water and your temperature is somewhat regulated. To get started, we'll take off this cover here, and as you can see, the electrical is not that great. Part of me is kind of surprised that it actually works, but hopefully we'll get this thing all taken apart, cleaned up, and back together, make it a little bit more user-friendly. So we got that main electric box taken off and everything opened up so you can see what it looks like inside. This back box here is your coil that creates your high voltage that creates a spark inside the burner that actually lights your fuel on fire and creates your ignition source. These two little spring tabs connect up here to these brass connectors that go in. Then you just have two rods inside the burner that arc across each other. The pump produces the high pressure, pumps in the fuel, atomizes it, and that's where you get your fire from. So these wires for the transformer. These wires are for the motor on your pump that actually does the pumping. And then we have this wire that runs up to the back of your motor. Just normal terminal block in there. If you're ever trying to figure out how to wire up a motor, most name brand motors will have a tag on them that will say how everything's wired up. So you can see there's numbers in there. You can kind of make out a 2, 3, and 4. Those are your terminals that are respectively match up with your line. So your black is going to be your line voltage, neutral is your white, ground is green. And up top is that vacuum switch I was talking about. Just it's a simple spring-loaded switch. When it goes down, makes contact. When it goes up, it's an open circuit, shuts everything off. So my plan is to mount this nice outlet box here using this offset connector. I'll have to put a couple more holes in the box to run these cord grips out. I'll need 3 of them on the box, one for the voltage in, one for the motor, and another one for the vacuum switch, and then run the electrical up top. So I got the holes drilled in the outlet box. I got the outlet box mounted up. I got all the wires running into the box. I got these two. You can see, redid the connections in the motor, redid the connections in the vacuum switch. I also extended this set of wires for the pump motor because they were a little short, and I have the main feed line coming in as well. So now I'll wire up the switches. We do have the schematic. This is the one that we're going to use because the previous one had the 2 switches, 1 vacuum switch, the burner, ignition, and pump. And that's all to it. Looks like a cluster of wires, but it's really not too bad. Well, everything fit in the electrical box. It was a tight fit, but we got it all in there. Combination of some wire nuts for the common terminals, then wherever it connected to, like the ground studs and the main connections on the side of the switches. I used the little spade connectors, and all heat shrink stuff because 1, that's all I have on hand right now, and 2, I like to overkill and overanalyze everything, and it's in a waterproof box. It shouldn't get wet, but in case it does, it's got watertight connectors. And I also did put a little drain hole on the bottom right there if it'll focus, just in case any water does get in there, it won't cause any issues. We went ahead and I took a little bit of sandpaper and sanded the contacts for the spark system just because they're a little dirty and we're in here. So the only thing that's left is to put this nice switch cover on the box and wire up the cord cap on the main power cord. So if you've never wired up your own cord cap before, it's a great thing to be able to do because you could make your own power cables for stuff that are just the right length. Say you had a chop saw sit on the bench that never moves and it's 12 feet to the nearest outlet. Well, a 10-foot extension cord isn't going to reach, and a 20-foot is going to be too long. You can go buy some cord, make your own power cable that's just the right length. You could fix an old extension cord, but if you've never done them and you don't know how to, so this is a 110. There's a green screw, a brass goldish color screw, and a silver screw. Green is ground, brass is your hot, and silver is your neutral. And that's pretty generally the color scheme for all your cord caps that you're going to run into. And if you buy a good quality cord cap, they usually come with the paperwork here, and they'll tell you right there what everything does. And the key to a good cord cap, putting it on, is this part here where it clamps down. You want to make sure that it clamps down on this black part of the insulation and not the actual wires themselves. If you clamp it on the wire themselves, if you get a pull on the cord, it's going to pull on where these are connected up top. It could potentially come loose. So you want to make sure it's clamped down on the outer insulation. Now it's all buttoned up, got all the covers on, cover the motor, cover the vacuum, got our cord cap on, ready to give this thing a shot. The wire hooked up, it's plugged in, let's give her a shot. I don't have the high pressure hose on right now, so it's just gonna be constantly pumping, but we'll see what we got. Now, pump works. And you can see how this vacuum switch works. Turn the pump on and then that goes down. Creates a contact. You gotta flip the burner on. Burner comes on, nice and warm. Now you got some hot water going. Since it's back up and running, we're gonna wash the truck. I'll give you a little sneak peek to the coming up project. We gotta fix a broken fender on this aluminum trailer for a friend. And I picked up that dump trailer over the weekend, needs a little TLC. So that's what we got coming up. Thanks for watching.